So after that, so yeah, actually documentation, next point. So every file should have a header describing what it is. Every function should have a comment block with it, and there'll be example, don't worry. And then inline documentation should appear on the lines before the code, not on the same line as the code. That sentence is sort of like self-contradictory because of inline documentation, but the idea is that you're gonna have comments like double slash on the same line. Don't do that on the same line, do the line before. It makes the code look more clean. Also the naming conventions for the variables. So let's go to the examples of documents. So here is the header. See, doc example is a file name and a short description. Nothing too special. So these names should be more meaningful. These are global variables, but made these less meaningful on purpose. So like global integer. So this is a number. Blah is 0 and a string, whatever, right? So this file only has one method, and you see a bunch of comments. So the comment does get very large, but it's good for our own purposes. So this only has one function, demo, takes in two parameters, s and t, which has no meaning in particular. And then you see, we know a g and blah is a global number, even though blah has no meaning. So blah it doesn't give you anything, doesn't have any information. But just from the prefix, we know this is a global integer. So this operation is legal, like just by looking at it. All right. So this is an example of like just local variable. So there's no global status, just a simple string out, which is demo. And all the function does is it checks if s is even. If it's even, it prints out demo. And if it's not even, it does nothing. And there should be a return at the end, but it's waypoint, so you can ignore the return, and then the compiler will put it in for you. So for example, like these lines, I'm not putting the comments like here. I'm putting the comments the line above, as I mentioned. Also, the comment should not be a direct translation of what this code does. So for example, here I have smod 2, which is 0 if it's even, so I put a not in front because I'm busy using the trick that 0 is false, anything else is 1 in C and C++. So this should not be like if smod 2 is 0, then do this. It should be more meaningful. So if s is even, something like this. All right, and yeah, that's the entire function. And in the comments, you have basically the template of the function. So a short description demonstrates some of the commenting standards. This detailed description is left blank here because this is done in the actual documentation and testing phase, I'm saying. So here just a placeholder for it. Parameters, no special meaning in this context. So because s and t are just numbers being put in, like there's no meaning attached to them. But you see here, if there was a because like the example I give here is that if it will have a division function, it will be a dividend and divisor, and then you have these numbers actually have rows and a meaning attached to them. So there will be the return type. This is not int. I screwed up. So return is void. And set effects is that it increments global blah. So g and blah, and displays demo if s is even. Doesn't throw any exceptions. No bugs, and then notes bugs should be listed first. Parameters basically have no meaning here, right? I was pointing out, and different bullets should be separated by lines. So there's no indentation. Paragraphs are no indent, but separated by line breaks. So for this, there is a template for the comment block, which is what I just talked about, and what to put in the comment block at different stages of development will be discussed later in the presentation. So that's documentation. So pre-implementation, header files. This is sort of specific to C++ almost, but then again, like for any other languages, this is a template for the class we're going to use. And there should be brief descriptions of each member field method. So the brief description in the block comment code, that should be in the source file. So like if you're using C++ example, that'll be the CPP files in front of the actual functions, but that line will be putting the .h header files as well to tell that line or those lines will be put as comments in the template file as well in the header, so that people can just read the header file and get a rough idea of what each function does. So corresponding source files have empty implementations with code blocks on top and basic driver programs. And for soccer only, there should be just initializing a master class and code run. So for SSL, be making initializing a coach and code run on coach. And for 2D, we call agent and make an agent, code run on agent. So full common block of all methods, as I said. So this should be the brief descriptions, parameters, and return values, because those are the templates. Those should be set in stone. Well, not set in stone, but those should be there now, so you can actually do this kind of comment. And all files should have a common block describing itself. As I said earlier, on the top it says the file name, what this file is, and then also the makefile that handles the dependencies. And you should sort of know how to do a makefile by now. In the implementation phase, this is where the actual coding starts. Pre-implementation, we start on the header files, and then implementation phase, we start on the source files. So one round of testing of core features, once the core feature is completed. So once the the basic communication stuff, this is where the first layer of testing that we have actually the correct inputs. So that should be the testing afterwards, after we've done the code for the core features. And in the implementation phase is where the different releases are produced. So when, for example, every time we complete 20 features or some other system that we are using, we have one release, and that's when one systematic testing comes through, a layer of QA, a simple QA on that milestone, for example. And then common blocks of all function, the method should be updated, with known bugs. So, for example, if your code doesn't work but sort of works, you should put the bugs there. Maybe notes on how if you're using a special algorithm, you should just put it on the notes quickly, and then you can refer back in the documentation phase to actually complete all the formal documentation. So in the documentation testing phase, the detailed description is filled here. So blocks of all functions should be filled. So common blocks are going to be filled now because the only thing we were missing before was a detailed description, and this should include even the implementation. So if you're using a fancy algorithm, using some special data structures, and you should be lay those out in a description. So it should be a paragraph long for each fairly important functions. If it's a trivial function, you can skip it, I guess. But for important function, those should be laid out, and you see there's a lot of writing and documentation going on, but it's good in the long run. And you should catch and fix any memory leaks. If it was missed from implementation, maybe you just missed it. This is the testing phase, right? You generate test cases, and in soccer, basically you run these games against yourself or some other team's code, and just keep on running games and see where your code crashes, essentially. And you fix bugs from here on, and by this point, the entire code should be done. It should be functional. It's capable of playing a full game for our purposes in the soccer playing AI. But for general code, is that it should be fully functional, and but maybe not optimized. And the next phase is continuous optimization, where you just keep on address all the known bugs, and you try to make each part of this design better. And essentially, the design should be modular, so that you can optimize one part of the code without affecting the other parts. And then in soccer playing, they'll be optimizing the movement functions and stuff, and maybe more strategies, more rules for different gameplay, for example. And yeah, that's it. That's what I have for you guys. I'll throw all these slides, this video, and the codes I used here. So the sample codes I gave you guys, these guys will be on where is it? Okay, so these guys will be on the web page as well. Well, you guys are probably reading this from the web page as well, so what it says is probably pointless. But yeah, okay.